Spice math. That's right. You can add it up, multiply it, man. Spice math. Okay. A couple things we're gonna learn today. Spice math. All right. Take some time, educate yourself. Spice math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Dottin.
Hi, I'm Erin Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Dottin.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hello students, and welcome to another episode of Spice Math. Today, we'll be tackling the Cartesian plane. Your tools needed are a pen and pencil, a ruler, and a notebook. Today's lesson is geared towards Form 1s to 3s, but is not limited to 4s, 5s, and anyone who sees it fit. At the end of the lesson, you should be able to briefly outline the history of the Cartesian plane, identify both the x and y axes, and plot points when given coordinates. A brief history on the Cartesian plane. The Cartesian plane was named after French mathematician René Descartes. He developed the Cartesian plane in the 17th century. It was said that Descartes liked remaining in bed late, and one day was watching a fly on his ceiling from his bed. He wondered how to best describe the fly's location, and decided to use one corner of the ceiling as a reference point. And thus, the Cartesian plane was born. The Cartesian plane, also known as a number plane, is a system used to plot points and hence draw graphs, using a system of rectangular coordinates. I know what you're thinking. What is a rectangular coordinate? Well, simply put, a rectangular coordinate is a pair of coordinates that is measured along two axes which are perpendicular to each other. For example, here. The Cartesian plane contains two straight lines intersecting at right angles. Here, we can see that we have a vertical line and a horizontal line. And at this point, a right angle is formed here, 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 and finally here. Our vertical line is called the y-axis, and a horizontal line, the x-axis. The point of intersection of these two axes is called the origin, and is denoted by 0, which is the starting point. Now, going back to our rectangular coordinate. Here we can see a rectangular coordinate comprises of an x component and a y component, which is surrounded by parentheses. We must give a coordinate a name. In this case, we named it A. So, if we say that A has an x component of 1 and has a y component of 1, what this is saying is that on the x-axis, there is a movement from the origin by 1 unit. On a y-axis, there is also a movement upwards by 1 unit. Now, we can express our information on our Cartesian plane. But to do this, I will invite a friend up to the stage.
Sir, how are you doing?
Here you go, sir.
Alright, so if I were to plot the point A11 that has coordinates 1, 1, I would first of all go to the origin. And this one, which is the x coordinate, indicates that I am moving 1 unit to the right on the x-axis. After I move 1 unit to the right on the x-axis, I am now going to look at the other coordinate, which is the y coordinate, 1. And that tells me I'm going to move 1 unit upward parallel to the y-axis. So the position of this point 1, 1 is denoted by the x here. 1, 1.
Thank you very much.
You're welcome.
So, as he said, you move from the origin 1 unit on the x-axis, which would be here, and then you move 1 unit on the y-axis, 1 unit upwards parallel to the y-axis, which would give you the point here. Once again, we did name our point, so we can't forget our little a right here. Now, what if we incorporate a negative coordinate? For instance, we have b. B contains, once again, a x value and a y value. However, in this case, we have to look at b being a negative number. How would we demonstrate this on the Cartesian plane? So once again, I would like to invite Mr. Philip to join us to demonstrate this.
Thank you. So for the point B, which has coordinates -1, 2, we have to pay attention to the fact that the x coordinate is negative. Whenever our x coordinate is negative, that means instead of going to the right from the origin, we are now going to go to the left. So from the origin, -1 means I am going 1 unit to the left on the x-axis. And then the y coordinate 2, +2, means that I'm going to go 2 units upward parallel to the y-axis, which is going to get me exactly at this point here, which has coordinates -1, 2. And the point is called B.
Thank you very much, Mr. Philip.
You're welcome.
So students, we can see that a Cartesian plane is somewhat similar to a number line. A negative x value would give us a movement from the origin to the left, while a positive value would give us a movement to the right. Now, a y-axis consists of both positive and negative numbers as well. In our first instance, our coordinate A, we had a positive value of 1. Thus, we had a movement upward of 1 unit. So, if we had a negative value, that means we would have a downward movement. Now, students, it's your turn. Design your Cartesian plane similar to mine with all your components and plot your points. Now, let's compare our answers. For A, we have 4 and 5. 4 for our x and 5 for our y. That means we are moving from our origin 4 units to the right. And then for our y, parallel to the x-axis, we are moving 5 units up. And this leaves us with this point here, point A. Now, when we look at coordinate B, we have a negative value for both our x and our y. That means from our origin on our x-axis, we will be moving 3 units to the left. And then on our y-axis, we would be moving 4 units downwards, giving us our point B. Point C, we have a negative x value and a positive y value, meaning from our origin, we are going to move to the left 1 unit. And then for our y-axis, we are going to move 5 units upwards because our y is positive, leaving us with point C. Point D, we have a positive x value and we have a negative y value. So, from our origin on our x-axis, we are going to move 4 places to the right. And then on our y-axis, we are going to move 3 places downwards because our y value is negative, leaving us with point D. So there we have it. A, B, C, and D. On this episode, we looked at the Cartesian plane. Thank you for joining us, and I hope to see you on another episode of Spice Math.
Won't believe it's just me.